Christmas Eve, let's go! Unstable diffusion. You enter a large crater of gray dirt where the grove is supposed to be. All around you, plants that you imagined were expected to be full of fruit are instead withered and broken. Oh, good thing we've been saving stars up this whole journey. A large group of elves have formed in the middle of the grove. But this volcano has been dormant for months. Without ash, the fruit can't grow. Okay. You look up to see a massive snow-capped mountain towering above you. It's not like there were other active volcanoes here. We've looked elsewhere. But our scanners show active magma flows. Clearly it's going somewhere. They finally notice you at the edge of the grove, your pack almost overflowing from the random star fruits you've been collecting. Behind you, elephants and monkeys explore the grove, looking concerned. Then the elves recognize the ash clouds slowly spreading above your recent detour. Before you can even form a complete question, another elf speaks up. Okay, new plan. We have almost enough fruit already, and ash from the plume should spread here eventually. If we quickly plant new seedlings now, we can still make it to the extraction point. Spread out. The elves each reach into their pack and pull out a tiny plant. The elves rely on important nutrients from the ash, so they can't be planted too close together. There isn't enough time to let the elves figure out where to plant the seedlings themselves. You quickly scan the grove, your puzzle input, and note their positions. For example, blah. The elves are pound signs, empty ground is periods. Outside of your scan, more empty ground extends a long way in every direction. To make sure they're on the right track, the elves like to check after round 10 that they're making good progress toward covering enough ground. To do this, count the number of empty ground tiles contained by the smallest rectangle that contains every elf. Simulate the elves' process and find the smallest rectangle that contains the elves after round 10. How many empty ground tiles does that rectangle contain? Okay. So today's wasn't too bad. We're just going to run through it. So the first thing we need to do, of course, is grab our input. That's just going to be a mutable list of mutable lists. To grab it in there is pretty easy. We just take each line, map it to a new mutable list, add it to the list, the outer list, basically. So grab this, map it into a mutable list of characters, and then add it to the outer list. And then that's our growth. And then basically what we need to do each time through is we want to do expand the grove. So if there's something on this edge, we want to add to it and so forth the other ones. Then we want to find a list of destinations that we need to go to. And then we need to move those destinations if applicable. So I kind of broke it down to 3 different functions, which actually worked out great for part 2. So let's go through them one by one. So expand grove is going to just take in a grove, and then if the top line contains any hashes whatsoever, we're going to add a new list to the beginning of the outer list that's nothing but periods. And then the same thing for the bottom, but instead of the first row, it's going to be the last row. The left and right are a little bit trickier because instead of doing just the first row or the last row, we need the first column or the last column. So we're going to map each first item, which is the first column, and to a new list. And if that contains a hash, then for every line and grove, we're going to add a new period at the beginning of the column. And then the same thing for right, except now we're going to do it for the end of the column and then add the period to the end of the column. So basically, if it needs to be expanded, and only if it needs to be expanded, do we expand it. I probably could have just done this as just make it way bigger than needed, but I kind of thought that there's a good chance that part 2 may have something that goes crazy with it, and it gets really out of hand really quickly, which may or may not have been the case. I don't really know, but this definitely works. So the next helper function is to find destinations. So this is basically going to be each elf's individual choice of where to go. And so it's going to take a grove and then the round number, because we need that to figure out which direction to look at. And it's going to return a mutable list of pairs of points. And that's going to be a point of XY for the elf's location and then a point to where the elf wants to move. And so that we're going to use that list of pairs to figure out, or to actually do the movement in the next step. And this one's not too bad. It's just a lot of code and a lot of kind of edge cases. So, but basically we're going to look at all of our Y's and all of our X's. And if it's an elf, then we're going to basically find out if it's by itself, because if it's by itself, it needs to stay put. And so we're just going to walk in the entire box of, all three above it, all three in the middle, and all three in the bottom. This will always count itself. So if count is greater than 1, we continue. Otherwise, we fall out. We don't add it to the list because it's good to go. So if we do continue, basically, as long as we haven't moved, we're going to just walk through all the directions. Since the directions can change order based on the round, basically the way I did it is to have just go through for 0 to 4, and then also have the round added to it, and then we get a module off of that. There's probably some cleaner way to do this, but basically, if it's round 0, for example, we're going to check 0 plus 0 first. That's a 0, so we're going to check north. And then if it's either the next round, or if the north did not provide anything, either way we move up 1 to check south, so on. The checking each location is fairly simple. So basically, if we're going to say it's false or it's not occupied, and then for each of the 3 locations in there, if it's occupied, we set occupied to true, and if it's not occupied, then we add that as a new list of destinations from our current point to the new point, and we set move as true, so we break out of the loop. And then we do that same thing for the other 3 directions. This is probably kind of one of the more tricky parts to code. Not that the math is hard or anything, but it's easy to kind of get lost in all the loops. And so once we're done, we're just going to return that list of destinations that we've added to as we go along. Now this still may have overlaps, but we only have to care about the overlaps and stuff now at this point. We don't have to care about any of the original position. And so the last part of that loop is to actually just move through everything. That helper function is going to take in a grove like before. It's going to take in the list of destinations that we just created from the last function up here. And then the first thing to do is find out if there are any that are moving to the same location. And basically, I just put them as a map for the second point. The second point is the actual destination point again, not the origination. I changed it to set just so I don't have to do extra work. And then for each item in that set, we're going to count how many times it shows up as the second element. And if that's more than 1, as in there's more than 1 elf going in there, we just remove all versions of it. So if there's 3 elves that all want to go to that same spot, we just pull them all out, they don't go. And then once that's done, all we have to do is just move the elves. So for each destination pair, then we set the original location to a period, and we set the new location to a hash. Elf is moved, we're good. So that loop will basically do everything we need to do for part 1. And then the last part is to find out how many blanks there are for the answer. And so I just do a min x, min y, max x, max y. And same kind of thing we did for the expanding function. We're just going to check if that, we're just going to check line by line until we find one that has any hashes in it, and that's the min y. And then the same for max, we're going to go from the bottom up, and then the same for x from the left to right. And again, same kind of thing we did before, where we're going to map that to the coordinates of the first or the coordinates of the last or whatever, and then to a new list, and if that list contains a hash or not. And then to go through and count the blanks, we just go through the standard double for loop, find all the ones that are blanks, add them up, and then return that value. That's it for part 1. Stick around for part 2. All right, 4056. And that's the right answer. You were 1 gold star closer, and I barely ranked. Okay, continue to part 2. It seems you're on the right track. Finish simulating the process and figure out where the elves need to go. How many rounds did you save them? In the example above, the round where no elf moved was round 20. Okay, figure out where the elves need to go. What is the number of the first round where no elf moves? Okay, that's easy enough because I already broke it into component parts. This will take no time at all. Famous last words. Okay. Okay, so all I need to do is grab my part 1. Actually, I don't even care about any of this stuff. I only care about this part. All right, and then I'm gonna go down to part 2 and throw that in there. And then instead of a for loop, I'm just gonna do var moved is true, and then var round is 0, and then while I cannot type, while moved, then do this, and then we need to round plus plus, and then check if the destination, actually this is going to be off by 1, right? Yeah, okay, so I'm going to increment it first since it's going to be off by 1 otherwise, and then if destinations is empty, because we've already broken it out basically, so if we know that nobody's going to move, then we return. The one thing I could see is maybe if you had 2 elves that are like stuck in a state where that neither of them could move, again like Conway Game of Life or something where they're stuck, but I don't know if that can happen. And actually I don't even know why I need this part because move true, but whatever, it doesn't matter. Okay, let me stop talking, start running. Okay. All right, 999. Okay, that's the right answer. Yeah, that was really fast. Okay, you are 1 gold star closer to collecting enough star fruit. You got rank 851. Cool. You have completed day 23. All right, 2 more days left. I will see you guys tomorrow.